Hi there, my name is Jason Bedreau. I'm the Director of Product Marketing here at NetBrain. I'm joined by Chris Lopez, and Chris is a Technical Marketing Engineer at NetBrain. In today's webinar, we're going to talk about a rebroadcast of some of the topics we discussed at Cisco Live in San Diego last month. Over the last few years at Cisco Live, we've been observing that automation has taken center stage as a topic of discussion. This as organizations are looking for solutions to the increasing demands on their network infrastructure and on the teams that manage that infrastructure. In this webinar, we're going to discuss how automation can be applied to network operations. This webinar will be recorded, and we'll send this recording out to you, everybody that's registered for this event, early next week. Also, if you have any questions, please submit them in your Q&A panel through WebEx, and either Chris or myself will be here to answer these while we're not presenting. So please keep those questions coming throughout the webinar. So when you look at what an operations team faces on a daily basis, it can be daunting. In a single enterprise network, in a single day, teams will likely make dozens of changes. This stemming from possibly hundreds of trouble tickets every day. As you trace those tickets back to the tools generating those, you'll see there's thousands of alarms generated from tools like SolarWinds or Splunk. That's as those tools are detecting and correlating on millions of events happening across the network infrastructure. So when we talk to our customers, we know that these numbers are staggering and they're overwhelming. Frankly, we are seeing that this is hitting a breaking point and teams are struggling to keep up with this volume of tickets. And when you take a look at those workflows, which teams are using to respond to these events, you'll see that they don't scale. So within a typical NOC, there's no shortage of those tools that are listening for those alarms, but the process to respond to a ticket or an event is highly manual. So I like this meme, which illustrates some of the frustration engineers face, bouncing between CLI windows and different NMS tools as they try to make sense of all the data at their disposal. To me, what this describes is a human acting as the middleware. So what do I mean by that? They're the middleware between the network, right? Typically one device at a time through the CLI. And they're the middleware accessing information from different tools, logging into those tools one at a time, trying to make sense of that data. So I'll pause here and we're curious to hear from you. What are the kinds of tools you're using when you're troubleshooting? If you don't mind, you can share that in the Q&A window. And the tools I'm talking about, again, are you relying primarily on the CLI for troubleshooting or using monitoring solutions, logging systems, packet flow, packet inspection? What are the tools you're using when you're troubleshooting? And is it really one tool or is it a combination of tools? So the result of what I'm describing, this human as the middleware, is that it's a very manual workflow. That's resulting in manual troubleshooting, manual security defense, which is another type of troubleshooting, and ultimately a very highly ineffective collaboration workflow as well. So we looked at this challenge at NetBrain and we saw an answer. The answer is to remove the human as the middleware and replace it with software. Software that has access to the live network through the CLI, through CLI automation. The CLI automation is used to collect and analyze data across any multi-vendor environment. And then that software can read data from your existing IT tools and NMS tools. So all this information in the network, it becomes accessible from a single console, right? With NetBrain, a network map is that primary user interface to the network. The result that we're trying to drive is a much more efficient and effective workflow, augmented by automation. So in today's webinar, we're going to talk about how automation is augmenting that workflow. And here's a view of a typical workflow in response to an IT event. Take, for example, a slow application. So enterprise network teams will typically have an event console like, I mentioned already, like a SolarWinds or a Splunk, that's going to listen and try to detect maybe there are anomalies that are occurring in the network, or maybe it's just a user calling the help desk to generate a ticket. They'll have these ticketing systems like ServiceNow or BMC Remedy or popular today for incident management. So this problem gets picked up by usually a tier 1 engineer, right? Then if it's not trivial, it's going to be escalated to somebody with more expertise who can help solve it. Then there's the remediation, the actual change or the actual fix that needs to go in place. And finally, the teams review what's happened to see how they can do better next time, right? This is typically done through a post-mortem analysis type activity. So the question is, what can we do to shift this workflow to the left? Because as the workflow progresses and issues escalate, the teams involved get more and more expensive. So how do we shift this workflow to the left? In other words, how can basic tier 1 troubleshooting tasks be automated? How can first level engineers take on more advanced troubleshooting, right? How can teams democratize lessons learned with each troubleshooting event to do better next time, or to even prevent issues from happening? So today's webinar is really going to be to talk about how this workflow can ultimately be shifted to the left through automation. We'll discuss how automation can be leveraged each step of the way through this workflow, from the moment an event is detected all the way through postmortem analysis, with the ultimate goal to reduce mean time to repair and make more effective use of operations teams during this response. So let's start with automation at the moment an event is occurring, event-triggered automation. Going back to that typical workflow, we'll take a look at the first engineer response. These teams are typically overworked and they're understaffed. And a large percentage of these tickets are closed without any resolution. Oftentimes teams use a code like NTF for no trouble found, and this usually indicates that a problem is intermittent, can't be replicated. So the challenge is that the majority of these issues will resurface again and again until someone's able to capture the data in real time or replicate the problem. So with automation, the crime scene can be captured at the moment of the event. For example, by integrating NetBrain with a console like SolarWinds or a ticket system like ServiceNow, a problem area can be documented automatically in what we call a dynamic network map. And a predefined diagnosis can be initiated at that same instant. So, right, this might be at, say, 2 a.m. There's a bandwidth spike, or there's a failover event. Now, when the first engineer arrives on the scene, take Jerry here, they're picking up a ticket that is already enriched with the resulting diagnostic, the map of the problem area. So we believe that a human, in fact, shouldn't have to touch a ticket as that first line response, but instead automation should be the first response. Sometimes we call this tier 0 response, basically done by a bot instead of a human. So I'll welcome Chris Lopez to show us what this event-triggered automation looks like with a live demo. Over to you, Chris.
Thanks, Jason. Hey, everyone. I'm Chris Lopez, and I'm going to be running a demo of event-triggered automation for you today. We've created an environment that closely mimics a production environment, as you can see with the headquarters and multiple branch offices. And I'm going to introduce the network event. See, we have a video server in our headquarters, and it's sending traffic to a client in one of our branch offices. And I'm going to pull up the view of the live server here. As you can see, here in the command prompt, traffic is being sent to the device. And on the right side, you can see that we're losing about 50 to 60% of our traffic at any one time, and we don't understand why. From here, we're going to begin our journey into NetBrain's just-in-time automation workflow. In our network monitor, we can see that an alert has been generated for a slow application. As you can see, this alert is very recent. On the right, you can see a column labeled incident number. And this is where the monitoring solution has actually created an incident ticket based on the alert that was generated. As I navigate into it, we'll be taken directly to our instance of our ticketing system, which in this case is ServiceNow. And you'll be able to see basic information such as the ticket number, who it's been assigned to, what time it was created. But in the section below, you'll be able to see where our monitoring solution has actually handed off information directly into NetBrain itself, based on information gathered from the alert. You're going to see 3 fields filled in: source IP, destination IP, and a NetBrain map URL. Now, the source IP and destination IP were entered by SolarWinds, which detected the alert based on NetFlow and CBQoS information relayed from the network devices. NetBrain is then using that information to create a critical path of the problem area and put a link back inside the ticket. And the value of this map link cannot be overstated. This is the machine providing diagnostic data to your engineers before they sit down to begin troubleshooting the issue. As I navigate to the map, we're going to see an application path of switches, routers, and firewalls between the server and its client. These are devices that we need to look at in order to solve this network issue, and this is information that might have taken your engineers a long time to figure out on their own with manual network operations and documentation. On the left, you're going to see a runbook with a couple of nodes executed here, and these represent the basic diagnosis of the network issue. This map, as you saw, was created at the moment of the network event, and so was this runbook. It was actually executed right when the dynamic map was created. It's important to emphasize that this could have happened in the middle of the night, when no one was available to respond to the issue and capture real-time data. So I'm going to start looking at the results of the runbook nodes. Here we can see NetBrain has pulled basic information from each of these devices using the following CLI commands. In fact, if I look at this panel below, I'll be able to see the live output of the CLI for each of these devices for each of these commands. The main value here is twofold. First, we've captured data at the moment of the event, which for intermittent issues is incredibly difficult to obtain. The second value here comes from scale. Here, NetBrain has executed 6 commands across 5 devices. But imagine if you needed to scale that up to 10 or 50 or 100, and how much time that translates into your engineers hopping between a bunch of device CLIs with a notepad performing a stare and compare. Next, I'm going to check out the results of the overall health monitor. Here we can see that the overall health monitor is looking for common indicators of performance issues such as input errors, output errors, CPU and memory utilization. And it's actually visualizing this for us directly on the dynamic map. I can see that in the context of physical health, I might have a problem up here around this link. I might need to investigate that a little bit further. And again, this enables us to get a closer look at specific parts of our network while still maintaining the map as interface functionality that makes NetBrain so powerful. The point here is that NetBrain's CLI automation is very accessible to network engineers, and that we're using the same information that they work with in a more targeted way. All right, that is event-triggered automation. Back to you, Jason.
Thanks, Chris. There are several benefits to automating that first response. With level 1 diagnostics automated, this opens up level 1 engineers to take on more advanced troubleshooting. So next we'll talk about how senior level engineers can codify their know-how into executable diagnostics, and how first level engineers can automate those and execute those through what we call interactive automation. So speaking of know-how, it's no wonder subject matter expertise in networking is so hard to come by. Networks have become incredibly complex over the last 5 or 10 years. So 3 examples I see which is validating this, right? First is that trends towards SDN and SD-WAN, and this is bringing a massive learning curve to the network management teams. So with a reported, what I found anyways, to be 57% of organizations looking to adopt SDN by next year, this change is coming whether we're ready or not. And then there's the skill set to manage the disparate vendors. There are over 100 network vendors. A typical enterprise network will typically leverage, say, between 6 and 12 of them. Different vendors for routing, switching, security, load balancing, etc. Each vendor coming with its own CLI, context, its own learning curve, etc. You don't need to look any further than Cisco's certification track to see what I mean. It used to be that a network could be managed end-to-end by one general engineer. Now, expertise is required across data center, across campus, for voice and video, and so on. And last month at Cisco Live, Chuck Robbins was talking about adding to the certification track for more DevOps, for more programming and automation skill set as well. So when issues occur, different skill sets are required to help identify the source of the problem. By making more senior level know-how accessible to that first response engineer, this leaves more time for those senior engineers to take on those more strategic projects that are going by the wayside. If this is done well, it can also mitigate the risk of engineers leaving an organization and taking all their knowledge with them. In order for senior engineers to do this, though, it has to be incredibly easy, because adding more overhead to a senior engineer's workload is just not going to get this done. Otherwise it's just a good idea in practice, but it's never going to be executed well. So this process of documenting and sharing know-how has to be near automatic. So senior engineers can use NetBrain automation to codify their knowledge into what we call executable runbooks. They don't need to know scripting to create this automation. It can happen almost automatically. It can be written once and executed anywhere across the network. So instead of manually documenting their subject matter expertise into playbooks or wikis, their workflows can be documented automatically as they're troubleshooting in NetBrain, and these resulting executable runbooks can then be run by any engineer across any part of the network. Then there's a different kind of expertise, the expertise required to operate different IT and NMS tools, like monitoring or packet inspection tools, for example. So referring back to that meme from earlier about the knock guy and that conveyor belt, each tool on that conveyor belt is basically what I call a data island. That valuable data may be hard to access if different team members don't have the access or skill set required to use each tool. So we looked at this challenge and thought about that old promise about a single pane of glass, right? That the industry has been promising this for years, that single pane of glass. We think a network map is the right context for that proverbial single pane. And that data from third-party tools, any data you're looking for, can be visualized in the context of the map. This might be, at a device or interface level. So at NetBrain, we made it possible to integrate your existing monitoring, security, or ITSM solutions. Anything that has an API interface can be integrated into NetBrain to bring the valuable data to one place. The goal is to make more effective use of your existing IT solutions, making them accessible to anyone that you want to have access to those tools, and most importantly, the data within those tools. So next, Chris will show us a live demo of this interactive automation with NetBrain. First, how subject matter expertise can be codified and shared. And next, he'll show how data from third-party tools can be integrated as part of that diagnostic response. So back to you, Chris.
All right, let's hop back into it. Where we last left off, we saw that our overall health monitor indicated some input errors between two devices on our map. As Jason was mentioning, it's important not only to integrate data from our third-party tools, but also to encode expertise from our higher-level engineers to facilitate faster resolution times. I'm going to show you something that does both of those things at once. Here, at this bottom panel, we're going to take a look at something called recommended actions. These are automation tasks that were defined by a higher-level engineer, and they're going to help shape the troubleshooting process of the Tier 1 engineer who picked up this ticket. Specifically, these are automation tasks related to pulling third-party data directly onto our dynamic map. And I've added them to the runbook, and I'm now executing them. Right now, NetBrain is making an API call directly to our monitoring solution, and it's pulling related information about each device on our dynamic map. Now we can see things like system uptime and response time, as well as a list of health metrics that were pulled straight from SolarWinds. And if I wanted to corroborate this information, I have a link directly to SolarWinds embedded inside the results. And it's not taking me to the main page, it's going to take me directly to the device page, eliminating any drill down that I'd have to do in the tool itself. But it doesn't look like I got anything too useful here, so I'm going to move on to the next one, PRTG. In effect, by integrating all of this data, I'm removing the need to leave the context of my problem area in order to gather data from my other tools, eliminating the data islands that Jason was mentioning earlier. So the results have come in now, and I have a searchable index of PRTG sensors below each device. If I wanted to navigate to, like, my NetFlow sensor, all I need to do is type it into the search bar, and it will immediately filter it out. So I can see I have had traffic on my NetFlow sensor. I have a link to my sensor ID. But also I can see that the status here is unusual. So that's definitely something to consider moving forward. I'm also going to take a look at my CBQoS sensor. And I can see that I have had a significant amount of CBQoS traffic, another link. And this is kind of indicating to me that we must have potentially a QoS issue. I'm not completely sure on how to troubleshoot that, but thanks to the recommendations from my superiors, I've been able to provide more useful information in this initial diagnosis. And I've been able to do this without having to leave the map at all. All right, back to you, Jason.
Thanks again, Chris. Next, we'll talk about how automation can help as teams collaborate with incident response. When collaboration or escalation is necessary, there are a lot of inefficiencies. Engineers are often duplicating efforts because they're just not on the same page or they're not aware of what the other team member is doing. And so the other thing that we see is finger pointing between teams. That's not uncommon at all. Whether it's the application team and the network team, the security team, the server team, there's always a lot of finger pointing about whose problem it is. So if you look at mean time to repair, right, MTTR, it's really a result of two things. What we call MTTI, which is, I think, the bulk of the challenge, with the repair being less time intensive. So when I say MTTI, I'm actually referring to two things. I mean the mean time to identify a problem. So in the context of collaboration, I'm going to talk about this in terms of escalation, in terms of handoff. But also MTTI can mean mean time to innocence. So right, just like I was talking about, we know the network is guilty until proven innocent. Unfortunately, this challenge falls on the network teams to prove that innocence to other teams, right? The app team, the server team, for example. And that's not always easy. So here's a good place. I always look for engineers to chime in. When I talk to engineers, this is a familiar challenge. So chime in on the chat or the Q&A window, rather, to let us know if your network team is facing a similar challenge. Do other teams assume that every application slowness issue is really a network problem? What percentage of the time is it really the network? Let us know in the Q&A window. Let's look at how automation can address these two challenges. So the answer we came up with is to automatically document user activities inside of a runbook. The runbook is embedded within the map URL so that everyone can see what their colleagues are doing as they troubleshoot alongside them. Perhaps this is used for escalation so that the Tier 2 engineer can see what has already been performed by Tier 1. So basically, a network map can help everyone understand who did what when and what was the result. Again, get everybody on the same page. So let's take a look at our third demo to see what collaboration looks like when workflows are automatically documented and shared across the team. So back to you, Chris.
Thanks, Jason. All right. Back in our lab, we've been able to identify a potential QoS issue. But at this point, I'm still acting as a Tier 1 engineer, and I'm not sure how to proceed. I'm going to need to escalate to a Tier 2 engineer, and I'm going to do that directly in NetBrain. See, attached to each runbook node is our @mention feature, which allows me to tag another engineer and provide them a link to both this map and all of the tasks that I've been performing so far. I'm still tagging myself, but just imagine that it's a Tier 2 version of me. So at this point, I'll navigate to the desktop to more fully assume the role of Tier 2 Chris Lopez. And I'll be able to see I've been mentioned inside of a runbook. If I navigate through the link, I'll be taken directly to the map that I was working on. I'll be able to see the results of all of the runbook nodes. And I'll be able to evaluate what the Tier 1 engineer did and what he was able to see. I'll be able to quickly come to the conclusion that this is a QoS issue, like he suspected. And I'll be able to apply my own Tier 2 diagnosis to this. So all the while I'm doing this, the Tier 1 engineer will actually have full visibility over this map and this runbook. So he'll be able to learn as I complete the troubleshooting effort. I'm going to start by verifying the application path. See, this is all related to a specific video application, and I'm able to see the live data, but what I don't see is how maybe this is different from the golden path, or rather the last healthy path that I was able to benchmark. So I'm going to go ahead and draw that. What we're going to see here is the network, or this application path, at the last time that I took a network benchmark, represented by this green line. As we go through it, we'll be able to see that this actually went through a different path during the last benchmark. Instead of going through US boss R1, it went through US boss R2. If I bring your attention back to the initial map, I'll be able to point out that boss 1 and boss R2 are in high availability mode, indicating to me that at some point we had a failover. I'm not entirely sure of the significance of this, but I know I definitely need to drill down into this a little more. So I'm going to go ahead and retrieve live data from each of these devices. At this point, I'll just pull the configuration file, and while that's running, I'm going to go ahead and set up a compare feature, which is going to allow me to compare the configuration files of both boss R1 and boss R2. Since they're in high availability mode, we shouldn't see too much of a difference between them. Okay, so we can see a few differences like host name changes, maybe a few of the tunnels are different. And down here is something pretty significant. Under their QoS policies, whereas US boss R2 has a 4 meg policy, US boss R1 only has a 512K policy, tipping me off that maybe we failed over to a bad config, and that's why we're having a slow application. Just to follow this up, since I'm pretty certain this is a QoS issue now, I'm going to go ahead and run a QoS QApp, which is essentially just the expression of NetBrain logging into each device, executing show policy map interface, and displaying the results for us on the map to tell us what traffic is being matched to what class and policy map, and if it's dropping anything. And again, the Tier 1 engineer will be able to look at this the entire time I'm troubleshooting and identify that this is what we should be doing in the event of a QoS issue. Once it's done running, we should be able to see whether or not we're dropping any traffic on any of these devices. And here it seems that we found 602K of drops on Ethernet 02, and if I look at the 5-minute rate table, I'll be able to see right there that's the smoking gun, and that's what we need to resolve in order to fix our slow application. Essentially, through all this, you're seeing how the escalation between the Tier 1 and the Tier 2 engineers facilitated via NetBrain, not only through being able to see the previous actions here, but also through being able to see the future actions as well, the ones that the Tier 2 engineer was able to take. So this troubleshooting effort also becomes kind of a teaching moment. All right, back to you, Jason.
Thanks again, Chris. Chris's demo showed how collaboration helps reduce that mean time to identify or mean time to innocence. Next, let's talk about that repair phase of a response workflow. So the repair phase might not be the most time-consuming, but it can be the most risky. So in fact, about 50% of outages can be traced back to a network change. That's the last thing we want to do when we're troubleshooting, is to make matters worse, right? So to avoid that, a lot of organizations have procedures and approvals to ensure changes are made carefully. When these approvals become just a rubber stamp process, that's when teams can run into challenges. So let us know over the chat window, or the Q&A window rather, if your organization has a good change process for documenting and improving changes, or maybe if not, what tools are you using, whether it's for ticketing systems, to make this change request and change approval process. Let us know in the Q&A window. We'll be curious to hear about that. So runbook automation can help here too. A runbook is used to define the network change and communicate that change plan across the team with an approver. The approval process can follow your traditional processes that I was asking about. For example, a change can be requested and approved through ServiceNow, and that approval will unlock a change runbook in NetBrain so that it's allowed to be executed. The last phase of that change process is to verify the impact of that change. This is typically done by verifying, say, a critical application or multiple critical applications inside of NetBrain to verify that they aren't impacted by that change. And that can also be done through runbook automation. I'll bring Chris back one more time to show us how change runbooks can make changes less risky. Chris?
Hey guys, let's bring it on home. Now that we've identified the nature of the QoS issue within our network, we're going to use NetBrain to remediate the problem. I'll begin by going into our network change module and initiating a new network change. We'll just call it modify QoS. We'll be taken to a unique runbook within NetBrain, specifically our change management runbook, that we're going to use to define the change, create a snapshot beforehand, and execute it. Since we know the nature of what we're trying to remediate, I'm going to go ahead and just load up a template here. In addition, I could also define the rollback procedure so I could remove this change as quickly as I appended. In addition, I'm going to go ahead and create a benchmark before, in case I needed to take a snapshot and restore it. Finally, I'm going to go ahead and approve this. We can approve this through NetBrain. We can also approve it through an external system using an API. And I just wanted to point out that when I asked myself to approve this message, I was also tagged within in the notification pane. So much like in the same way I navigated to this pane as the Tier 2 engineer, I would also be able to navigate to this pane, or to this map in this runbook, as the approving lead. But it looks like we're in pretty good shape now, so I'm going to go ahead to the execute pane, and we're going to go ahead and push this change. There are 3 ways to execute a change within NetBrain. You can go one by one automatically, you can go in batches automatically, and you can go one by one manually. Since this is a pretty simple change, I'm going to go ahead and push in batches automatically. And we're going to go ahead and execute this. At this point, you'll actually be able to see the live output of NetBrain logging into this device, pushing these changes, and then logging out after performing a do-write. Once this is done, I'm going to execute a benchmark afterwards, and this one's actually for verification purposes. I want to make sure that this change has gone through as we intended it to. Much like I found the differential between the 2 config files, I'm going to compare the benchmark before to the benchmark after and make sure that the QoS policy has been upgraded. As we go here to USBoss R1, we can see that we've gone from a 512K policy to a 4 meg policy, meaning we shouldn't have any QoS issues anymore. If that's completely accurate, though, we shouldn't be losing 50 to 60% of our traffic. And there you have it. With NetBrain's change management module, we have successfully remediated the poor QoS, and we are no longer experiencing a slow application. This is also done in a way that's very auditable, because in our network change log, you'll be able to see a list of what changes have been done, what's their status, who created and approved it, and when. All right, back to you, Jason.
Thanks once again, Chris. Last, let's discuss how automation can help drive continuous improvement into this incident response workflow. Following an outage, a lot of teams will typically hold a post-mortem review. This is where they ask the question, how can we do better next time? Or how can we prevent this problem from happening again? This is a valuable opportunity to learn from an outage. Or as one customer once put it to me, understanding the art of an outage. For the people involved in that incident, they may walk away a bit wiser, but what about the rest of the team who wasn't involved in that troubleshooting event? How can we ensure that they too are equipped with the lessons learned going forward? So remember that runbook earlier in the demo which Chris showed, which was automatically documenting the activities in that response workflow, documenting activities across different team members? So the important steps within that runbook can be saved as a template. This is what we talked about in the beginning of that discussion, shifting the workload to the left. This runbook can be shared with the first response engineer so they can execute it the next time a similar problem occurs. Or even better, this runbook can be configured to execute at that moment an event occurs, before that first engineer even opens the ticket. Remember that trigger diagnostic that Chris showed in his first demo. Or again, maybe this automation is actually proactively scheduled across the network infrastructure. Maybe you found a configuration issue and you want to know if this issue exists anywhere else in the network. You can run this diagnosis proactively by scheduling it to recur across the entire infrastructure. So that's it for today. I'll just use this slide to kind of recap the different chapters of the webinar today. First, we talked about automation before an event, before an engineer even opens a ticket, rather. How engineers can be equipped with more senior level subject matter expertise, make that expertise executable. How automation can help document activities to help teams get on the same page when they're troubleshooting, minimize finger pointing. How it can be used to drive safer network changes, and ultimately how we can drive continuous improvement into our workflows through proactive automation, taking lessons learned from each incident. So we hope you enjoyed today's event. Keep typing those questions into the Q&A panel within WebEx. Chris and I are going to be answering those through the Q&A chat, or if we think that a question is relevant for the entire audience, we'll ask that question out loud over the phone, and we'll try to answer that for everybody else to hear on the phone as well. So if we're quiet over here, just know that we're going to be kind of addressing those questions as they come in, so don't feel like you have to leave if you have more questions. Otherwise, thank you so much for joining us today. Hope you have a good day. Bye-bye.